name OLAP definition. We have seen the ETL process. Now we'll go for the OLAP definition. We have already studied the data warehouse architecture. Today's lecture we will see the OLAP definition, online analytical processing. OLAP, online analytical processing. This is the very important task of data warehouse. It helps in data analysis. It helps the decision makers in taking the decisions. It is subject oriented. It is useful for the data analysis and used by the knowledge workers. That means it is useful to the analysts, to the managers, enterprises, and so on. It facilitates the decision support. It is not related to the transactional data. We know that OLTP, that is online transaction processing, it is the transactional data, which is not focused here. The OLAP handles historical and consolidated data. For the database design uses For database design, it uses star schema, snowflake schema, and the fact constellation. The database design is subject oriented. It is integrated and the data should be represented in a single view form. The OLAP is very important to handle the complex queries. OLAP data cube. OLAP basically handles the multidimensional data. So to handle the multidimensional data, the data is represented in the form of a data cube. So in the diagram, you can see it is a three-dimensional time, sales, and profit. And each cell represents the according sales and the corresponding profit over a time dimension. The data can be viewed in the form of a data cube. So it consists of dimension tables, fact table. The fact table again consists of measures and the keys. We'll see all these concepts in detail while learning the concept schema or star schema, snowflake schema. The example is all electronics or a very famous example with the sales dimension. The dimension tables are here item, time, and the profit. The fact table consists of the different primary keys as in foreign keys of all these dimension, time, item, profit, and also it consists of the measures. These are the dollars sold or unit sold, which you'll see in later in detail. The n-dimensional base cube, ND base cube, is known as base cuboid. The topmost cube is the 0 dimension, so 0D cuboid. The 0D provides the highest level of the summarization. It is also called the apex cuboid at the top of the cuboid. The lattice of cuboid forms a data cube. So what is a lattice? Let's see. This is the lattice for the dimension table. As you have studied in the discrete mathematics, what is a lattice? It is having a unique list upper bound as well as it should have unique greatest lower bound. In this case, for the time dimension, the time may be represented in terms of days, months. So 12 months forms an year, 365 days forms an year. Then the number of quarters, 3 forms an year. Similarly, we can represent the year by using the number of weeks. So we have this lattice where year is at the top or apex of the lattice and the day at the bottom. So such kind of concept hierarchy is useful in case of the OLAP. Here is another example of the lattice: time, item, and provider. So this we have the three dimensions. So at the base we are considering the all the three dimensions. So it is a 3D cuboid. On the above level of it, the time item, then we have time provider, and third one is the item provider. So at this point we are considering the 2D cuboids, only two dimensions, so it is called as the 2D cuboid. Again, on the top of it we have the dimension time, item, provider. So at each node we have a single dimension, so it is called as a 1D cuboid. And at the top of this lattice we have represented all. That means it is having 0D, or it is also called as opaque cuboid. So this is a very famous example of the lattice. So this is how we have defined the OLAP. It is used for online analytical processing. So very complex data, complex queries can be handled by using the OLAP. Again, it works on the historic data. So once we have stored the OLTP or internal external sources data for a longer period of time, we work upon it and it is a historic data. So the OLAP is very useful for the managers, knowledge workers, enterprises. Thank you.